So in this video, we're going to look at the process of going to the reduced row echelon form. Okay, so for the reduced row echelon form, we need leading ones essentially, and then where there's a 1 in the column, every other entry is 0. Right, and if we do zero out any rows, that we can just switch them, right? Perform proper row operations to put them towards the end, right? So we'll take a look at this example, right? And so the first thing is to put it into the augmented matrix. So the augmented matrix would look like this. -3, 1, 3, 6, -5, 0. All right, so the first thing I'm going to do, so I have 1 right there in the corner in that first entry. So I'm going to start here and just try to zero out everything below it. Right, so I'm going to do 2 row operations at a time here for this first step, just so we can see, just to, in the interest of saving a little bit of time here. So the row operation I'm going to do is I'm going to multiply -2 by R1, and I'm going to add it to R2, and that's going to be my new R2. Right, so in other words here, I'm going to write it here to the side just so you can see the operation that I'm doing for just the first one here. So when I say 2R1, right, so what I do, it's going to be 2 times 1, 1, 2, 9. And then over 2, 4, -3, 1. All right, and that is 2, 2, 4, 18. And then add it to 2, 4, -3, 1. That's just kind of my side work here. Hold on, -2. So negative, 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 negative. So when I add that, I get 0, 2, -7, -17. Excuse me. All right, so that is going to be my new row here. 0, 2, -7, 17. All right, and then do the same thing here. The other operation is -3 R1 plus R3, and that'll be my new R3. So if I do that again, multiply the top by -3, add it to the one below it, we're going to get 0, 3, -11, -27. Okay. All right. So now, see, I have here my first here one where 1, everything else is 0. So that's my goal to do next. All right. So what I'm going to do next, the next row operation here is I'm going to first get a 1 here. So I'm going to multiply 1/2 by R2. All right, so if I do that, right, my new augmented matrix is 1, 1, 2, 9, 0, 1, -7/2, and then hold on a second here, I'm missing, that is -17. All right, -17 over 2, and then 0, 3, -11, -27. All right, so again here, focusing on 1 here, and the next step would be to see if I can get a 1 down here by the next row operation. That'll be -3 R2, and then add that to R3. Okay. All right. Excuse me. So that leaves me at 1, 1, 2, 9, 0, 1, -7/2, -17/2. And when I do that, I'll get 0, 0. So when I do these operations, I get -1/2 and then -3/2. Okay, not quite 1, but I can fix that by multiplying by -1/2, or excuse me, -2 R3 to give me that leading one. So now we have 1, 1, 2, 9, 0, 1, negative 7 halves, and then negative 17, that's 77. And then down here we get 0, 0, 1, 3. All right, so I have here, right, my leading ones, right? So on that part, I have achieved that end, right? Now it's not quite reduced row echelon form, right? Because if we look at the rules here, I posted in the module from our textbook, right? Everything in this column where the ones are, everything else should be 0, which I'm not quite there yet, okay? So that's gonna be my next goal. What I have here is called the row echelon form, right? But we go the extra step to get the reduced row echelon form, excuse me, because it provides more structure. And actually what we find out is whatever the augmented matrix that we begin with, when we're in the reduced row echelon form, that matrix is unique, right? So any system that has that solution, right, reduces to this reduced row echelon form matrix, right, which is a good thing to know here, right? So now how do we essentially work our way back here, right? So the way we started with the top corner, now I'm going to look at that middle row to try to get a 0 above it, right? So the way I'm going to do that is I'm going to multiply negative R2 plus R1, and that's going to be my new R1. All right, so when I do that, right, negative 1, so we get 0, and then we get 7 halves plus 2 is 11 halves. And then positive 17 halves plus 9, we get 35 halves. All right, and then the rest remains the same. Okay, all right. All right, and then slowly but surely, right? So I know here we can use a computer or a calculator here, but I am going to ask you to at least do one of these, a basic one like a 3x3 or something of that sort, or a 3x2 where you are required to do the row operations by hand. Okay, so now I have the second column is good, right? There's a 1, everything else is 0. So now the next one here is, now let's focus on R3 to kind of look above it and try to 0 out everything else in that column. Right, so the first one we'll do is we'll do 7 halves R3 plus R2. And that'll be my new R2. Right, so 0, 0. That one remains the same. And when I multiply by 7 halves, up here we get 0, 1. That becomes 0. And then 17 halves becomes 2. Right, so we get 21 halves minus 17 halves, 4 halves, which is 2. And then I'll do the other operation here at the same time here, which would be negative 11 halves R3 plus R1, right? So that'll eliminate the other term here. So that gives me 1, 0, 0, and 1. Right, so negative 11 halves plus 3 is negative 33 over 2 plus 35 over 2 is 2 over 2, which reduces to 1. Okay, and now we are in reduced row echelon form, right? We have these ones here, right? And everything else in that column is 0, right? So now this actually provides me with some structure here. I remember each of these columns represents my x, my y, my z, right? So what that tells me is that my solution is x equals 1, y equals 2, and then z equals to 3, right? Or my solution vector being 1, 2, 3. Okay. All right. So that is how we arrive at the reduced row echelon form and how we interpret the results here. Right now, in some cases, so I'm going to go over not the operations, but so much how to interpret the results here. So this is from our textbook. This is, if you've noticed the textbook has these archetype equations that it referenced throughout the book, right? And these are just a standard set of equations. It's the same linear system throughout, so we can kind of analyze the different solution sets that we get. Now, this first one is this of archetype 1, and here is the augmented matrix for that. So it's 1, 1, 2, 1, 1, 8, 1, 1, 0, 5. So we reduce this, we do the reduced row echelon form, we do a bunch of row operations here, and the reduced row echelon form looks something like this. Okay, and again here, right, the first three columns are x1, y1, or x1, x2, x3, or xyz, whatever you want to call it. Now this one is different than the previous example because here you see we get we only have two of these leading ones, two of these pivots here. All right, so now we have a free variable, right? That free variable being our x3, right? So when that happens, the way we interpret this is we could say, all right, well, x3 doesn't really have a unique solution, right? So x3, I can just call it t, right? Some parameter. It can be whatever I want. And then if I go up here, well, how do I interpret that? Well, the way I interpret that is x2 minus x3 is 2, but I already defined x3 as t. So that means that x2 minus t is 2, or x2 is equal to t plus 2. All right, and then the top one, we have x1 plus x3 equals to 3, right? But here, right, x3 is my parameter t. So x1 is negative t plus 3. So my solution vector, right, is the vector negative t plus 3, t plus 2, and then t. All right, so here we have a free variable, right? All right, and that's what we do when we don't have a unique solution for all of those variables, which can occur, right? We could still get reduced row echelon form, we can still do that, but it's just in the interpretation. And more of that in the next video that we'll do here.